Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. I am Sudhir MK. In this class, I am going to explain about relations and functions. And this is Relations and Function Class 5. In this class, I am going to explain about types of functions and problems related to it. Please subscribe the channel for more video notifications. First we see definition of one-one function. A function f from a to b is called one-one function if the images of different elements are different. If different elements have different images, then that function is called as one-one function. We consider example, suppose you consider this function. Now here different elements have different images, so therefore this function is one-one. Now here different elements have same image, therefore this function is not one-one. This function is one-one and this function is not one-one. If it is not one-one, then it's called as many-one function. Now here 1 and 3 have same image, so therefore this function is not one-one function. So next we see how to verify whether the function is one-one or not. A function f from a to b is one-one function if for every x1, x2 belongs to a, if f of x1 equal to f of x2 implies x1 equal to x2. If f of x1 equal to f of x2, then we have to get x1 equal to x2, then only the function is one-one. So next we see definition of onto function. A function f from a to b is called onto function if all the elements of codomain are images. If all the elements of codomain are images, then it's called as onto function. Now we say how to verify whether the function is onto function. A function f from a to b is onto function if for every y belongs to b, there exists an element x in a such that f of x equal to y. That is, for every y belongs to b, there exists one x belongs to a such that f of x equal to y, then that function is onto function. Consider example, we consider this first function. Here all the elements of codomain are images. Now here all the elements of codomain are not images. So therefore this function is onto function. And this function is not onto function. A function which is not onto, it's called as into function. Now here b is not image, so therefore this function is not onto and it is into function. Next it is bijective function. A function f from a to b is called bijective function if it is both one-one and onto. A function which is one-one, it's called as injective. A function which is onto is called as surjective. A function which is both injective and surjective is called as bijective function. One-one function is called as injective, onto function is called as surjective. A function which is both injective and surjective is called as bijective function. Next we consider one example. Now we consider this function. Now here different elements have different images, so therefore this is one-one function. And here all the elements of codomain are images, so therefore this is onto function. This function is both one-one and onto, therefore this function is bijective function. So this function is bijective function. Next we discuss some problems. These problems are from exercise 1.2. In last class we studied many problems. So now this is problem number 6. State whether the function f from R to R defined by f of x equal to 3 minus 4x is one-one, onto or bijective. Justify your answer. You have to check whether this function is one-one, onto. If it is both one-one and onto, then it is bijective function. Now first we verify whether it is one-one function. Now here it is given f of x equal to 3 minus 4x. We take f of x1 equal to f of x2 where x1, x2 belongs to R. Now here it is given f of x equal to 3 minus 4x. So therefore f of x1 equal to 3 minus 4x1 and f of x2 is 3 minus 4x2. And we can cancel here 3 we get minus 4x1 equal to minus 4x2. Again we cancel minus 4 and we get x1 equal to x2. Since f of x1 equal to f of x2 implies x1 equal to x2, this function is one-one function. So therefore f of x is one-one function. So next we verify whether it's onto. We take f of x equal to y where y belongs to R. Now it is given f of x equal to 3 minus 4x. So therefore 3 minus 4x equal to y. And we can write it as 3 minus y equal to 4x. Therefore 4x equal to 3 minus 5. So we have to solve for x. So we can write x equal to 3 minus y divided by 4. And 3 minus y divided by 4 is also a real number. So therefore this function is onto function. Therefore f of x is onto function. So next problem, state whether the function f from R to R defined by f of x equal to 1 plus x square is one-one, onto or bijective function. Justify your answer. Here also you have to verify whether it is one-one, onto or bijective. Now first we verify whether it is one-one function. Now here it is given f of x equal to 1 plus x square. We take f of x1 equal to f of x2 where x1, x2 belongs to R. Now here f of x equal to 1 plus x square. So therefore f of x1 equal to 1 plus x1 square. And f of x2 is 1 plus x2 square. And we can cancel 1 and we get x1 square equal to x2 square. and we can write x1 equal to plus or minus x2. Now here x1 equal to plus x2 or x1 equal to minus x2, both are possible. So therefore f of x is not 1 function. Now we justify this. We consider x equal to 1. Then f of 1 is 1 plus 1 square. 1 plus 1 square is 2. Also f of minus 1. When x equal to minus 1, we get 1 plus minus 1 square. Again it is 1 plus 1, it is 2. Now here f of 1 is 2 and f of minus 1 is also 2. Now different elements have same image. So therefore this function is not 1 function. Now here different elements have same image. So therefore this function is not 1 function. So next we verify whether it is onto function. We take f of x equal to y, where f of x equal to 1 plus x square. Therefore we can write 1 plus x square equal to y implies x square equal to y minus 1. Therefore x equal to root of y minus 1 does not belongs to R. So therefore f of x is not onto. To justify our answer, take y equal to 0. When y equal to 0, we get x equal to root of 0 minus 1, that is root of minus 1. And root of minus 1 is not a real number. Therefore 0 is not image of any element. So therefore this function is not onto function. So next problem, let A be the set of all students of a class 10 in a school. Let f from a to n be a function defined by f of x equal to roll number of student of class 10. So that f is 1 but not onto. Now we have to prove that this function is 1 but not onto. Now first we prove that this function is 1. So since different student of class have different roll numbers, this function is 1. Now here different student have different roll numbers, therefore this function is 1 function. Now we verify whether it is onto function. Since there are only 50 students and these students have roll numbers 1 to 50, then the number 51 in n is not a roll number of any student of the class. Hence the function is not onto. Now here we have only 50 students, therefore roll number is only 1 to 50. Therefore number 51 is not related by any element. So therefore this function is not onto. So here all the elements of codomain are not the images. So therefore this function is not onto. The next problem, prove that the greatest integer function f from R to R given by f of x equal to greatest integer function of x is neither 1 nor onto, where greatest integer function denotes the greatest integer less than or equal to x. We know that greatest integer function gives the greatest integer which is less than or equal to given number. We have to prove that this function is neither 1 nor onto. Now first it is 1. Now here it is given f of x equal to greatest integer function of x. We consider x1 equal to 1.4 and x2 equal to 1.5. We give some example and we prove this function is not 1. Then greatest integer function of 1.4 is 1. The greatest integer less than or equal to 1.4 is 1. And greatest integer function of 1.5 is 1. The greatest integer less than or equal to 1.5 is also 1. Now here greatest integer function of 1.4 equal to greatest integer function of 1.5. So therefore f of x1 equal to f of x2, but x1 equal to not x2. Now here 1.4 is not equal to 1.5. So therefore this function is not 1 function. Now here different elements have same image. So therefore this function is not 1 function. So next we verify whether this function is onto function. So since only integers are the images, f of x is not onto. Here images are only integers and other numbers are not images. So therefore this function is not onto since all the elements are not images. So this function is not onto function. Now we say diagrammatic representation of this function. Now here greatest integer function of minus 1 is minus 1. Greatest integer function of 0 is 0. Greatest integer function of 1 is 1. And greatest integer function of 1.4 is 1. Greatest integer function of 1.5 is also 1. Greatest integer function of 1.9 is also 1. And greatest integer function of 2 is 2. Greatest integer function of 3 is 3. All these elements have same image. Therefore this function is not 1. Now here only integers are images and these decimals are not images. So therefore this function is not onto. Therefore this function is neither 1 nor onto function. So next problem, show that the modulus function f from R to R given by f of x is mod x is neither 1 nor onto, where mod x is x if x is positive or 0 and mod x is minus x if x is negative. You have to prove that modulus function is neither 1 nor onto. First we prove it is not 1. So here also we take some example. It is given f of x equal to mod x. We take x1 equal to 1 and x2 equal to minus 1. Here we have mod of 1 is 1 and mod of minus 1 is also 1. So therefore mod 1 and mod of minus 1 are same. So therefore we can write f of x1 equal to f of x2, but x1 is not equal to x2. So therefore this function is not 1. So here different elements have same image. So therefore this function is not 1 function. So next we verify whether it is onto function. Since only non-negative reals are the images, f of x is not onto. Here also only non-negative reals are images, negative numbers are not images. So therefore this function is not onto. We consider diagrammatic representation. We consider mod of -2. Mod of -2 is 2. Mod of -1 is 1. Mod of 0 is 0. Mod of 1 is again 1. Mod of 2 is 2. Mod of 3 is 3. Mod of 4 is 4. Here different elements have same image. So therefore this function is not 1, 1. And here negative numbers are not images. So therefore this function is not onto. So this function is not 1, 1 and not onto. The next problem, show that the signum function f from R to R given by f of x equal to 1 when x is greater than 0, 0 if x equal to 0 and -1 if x is less than 0 is neither 1, 1 nor onto. So we have to prove that signum function is neither 1, 1 nor onto. First we prove it is not 1, 1. Here it is given f of x equal to signum function of x and we take x1 equal to 1 and x2 equal to 2. Then signum function of 1 is 1 and signum function of 2 is 1. For any positive number, signum of that is 1 only. So signum function of 1 is 1. Signum function of 2 is also 1. Now here signum function of 1 is signum function of 2. But 1 and 2 are not equal. So therefore we can write here f of x1 equal to f of x2. But x1 is not equal to x2. So therefore this function is not 1, 1. So this function is not 1, 1 function. So next we verify whether it is onto function. Since only -1, 0, 1 are images, f of x is not onto function. Now here only -1, 0, 1 are images, other numbers are not images. So therefore this function is not onto function. We draw diagram of signum function. In signum function all negative values are related to -1 and 0 related to 0 and all positive numbers related to 1. Now here different elements have same image, so therefore this function is not 1, 1. And here all the elements are not images, only -1, 0, 1 are images, so therefore this function is not onto. Therefore this function is neither 1, 1 nor onto function. The next problem, let a equal to 1, 2, 3 and b equal to 4, 5, 6, 7 and let f equal to 1, 4, 2, 5, 3, 6 be a function from a to b. Show that f is 1, 1 function. But show that this function is 1, 1 function. Now we prove this function is 1, 1 function and here it is given f is 1, 4, 2, 5, 3, 6. That is 1 is related with 4, 2 is related with 5 and 3 is related with 6. Now here f of 1 is 4, f of 2 is 5 and f of 3 is 6. Now here different elements have different images, so therefore this function is 1, 1 function. So since different elements have different images, this function is 1, 1 function. The next problem, let a and b be two sets. Show that f from a cross b to b cross a such that f of a b equal to ba is bijective function. We have to prove that this function is both 1, 1 and onto function. Now first we prove this is 1, 1 function. Now here it is given f from a cross b to b cross a with f of a b equal to ba. Now we take f of a1 b1 equal to f of a2 b2 where a1 b1 a2 b2 belongs to a cross b. Since f of a b equal to ba, we can write f of a1 b1 equal to b1 a1 and f of a2 b2 is b2 a2. Now here two order pairs are equal, therefore b1 equal to b2 and a1 equal to a2. Using this, we can write order pair a1 b1 equal to order pair a2 b2. So since a1 equal to a2 and b1 equal to b2, we can write order pair a1 b1 equal to order pair a2 b2. And here if f of a1 b1 equal to f of a2 b2, we get a1 b1 equal to a2 b2. Therefore this function is 1, 1 function. Therefore this function is 1, 1 function. Next we prove this function is onto function. So let b comma a belongs to b cross a. We take one order pair b comma a belongs to b cross a. Then there exists ab belongs to a cross b such that f of ab equal to ba. For every order pair ba, there exists one order pair ab in a cross b such that f of ab equal to ba. So therefore this function is onto function. Now since this function is both 1, 1 and onto function, this function is bijective function. So f of x is bijective function. The next problem, let f from n to n defined by f of n is n plus 1 divided by 2 when n is odd and n by 2 if n is even. State whether the function f is bijective. Justify your answer. Now f of n is n plus 1 divided by 2 when n is odd. When n is odd, you have to add 1 and you have to divide by 2. When n is even, you have to divide that number by 2. You have to verify whether this function is bijective. Now we verify whether it is 1, 1 function. We take x1 equal to 1 and x2 equal to 2. Now here x1 is 1 which is odd number. So therefore f of 1 is 1 plus 1 divided by 2 and 1 plus 1 divided by 2 is 1. And here x2 is 2 which is even. So when it is even number you have to divide directly by 2. So f of 2 is 2 by 2 and it is also 1. Here we get f of 1 equal to f of 2 but 1 is not equal to 2. So it is f of x1 equal to f of x2 but x1 is not equal to x2 form. So therefore this function is not 1, 1 function. Since this function is not 1, 1 function, this function is not bijective function. So next problem, let a equal to r minus 3 and b equal to r minus 1. Let f from a to b defined by f of x equal to x minus 2 divided by x minus 3. If f is 1, 1 and on 2, justify your answers. Here a set is r minus 3, that is real numbers without 3, and b equal to r minus 1, that is real numbers without 1. And function is from a to b defined by f of x is x minus 2 divided by x minus 3. You have to verify whether it is 1, 1 and on 2. Now first we verify whether it is 1, 1 function. So here we consider f of x1 equal to f of x2, where x1, x2 belongs to a. And here it is f of x is x minus 2 divided by x minus 3. Therefore f of x1 is x1 minus 2 divided by x1 minus 3. And f of x2 is x2 minus 2 divided by x2 minus 3. We cross multiply this and we simplify. We get x1 minus 2 into x2 minus 3 equal to x2 minus 2 into x1 minus 3. When we multiply again, we get x1 x2 minus 3x1 minus 2x2 minus x minus plus 6 equal to x1 x2 minus 2x1 minus 3x2 minus x minus plus 6. And here x1 x2 get cancelled and 6 get cancelled. So remaining is minus 3x1 minus 2x2 equal to minus 2x1 minus 3x2. We take minus 2x1 to this side and minus 2x2 to this side, and we get minus x1 equal to minus x2, and we can cancel minus and we can write x1 equal to x2. Now here f of x1 equal to f of x2 implies x1 equal to x2. Therefore this function is 1, 1 function. So this function is 1, 1 function. So next we verify whether it is onto function. Consider f of x equal to y, where y belongs to b. Now here it is given f of x equal to x minus 2 divided by x minus 3. So therefore x minus 2 divided by x minus 3 equal to y. We simplify for x and we can write x minus 2 equal to y into x minus 3. Multiply this again and we get x minus 2 equal to xy minus 3y. We have to solve for x. Take xy to this side and we get x minus xy equal to 2 minus 3y. Take x common outside and we get x equal to 2 minus 3y divided by 1 minus y. And 2 minus 3y divided by 1 minus y belongs to a. Since y is not equal to 1, this number is a real number. Therefore x equal to 2 minus 3y divided by 1 minus y belongs to a. Therefore this function is onto function. Therefore this function is both 1, 1 and onto function. That's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe to the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.